Welcome to the Better Buildings, Better Society podcast. Twice a month, we interview interesting individuals and get insight into what they think makes building better members of society. Subscribe to our podcast and share with your friends. Hi, I'm Stephen Forrester, founder and principal of DMA Engineering. My passion lies in the built environment and in the mechanical systems that keep buildings running at their optimum efficiency, while at the same time provide the best possible health and comfort to their occupants. In this way, DMA is absolutely committed to making buildings better members of society. This podcast focuses on energy efficiency through the eyes and experience of building industry professionals. Together with my guest, I will lead all of us on an exploration of how to build better energy efficiency buildings, how to save our clients time and money, and offer practical advice for those interested in the built environment. Join me, a mechanical engineer, outdoor enthusiast, and green advocate as I interview guests with leading edge ideas for creating better buildings and a better society. Hello again. I'm Stephen Forrester, principal of DMA Engineering. Thanks for joining us for another episode of Better Buildings, Better Society. This week, we are privileged to have Joshua Vermillion, tenured associate professor in the School of Architecture at UNLV. He is an expert in digital craft as a medium, material, and method, and has spoken, published, and presented peer-reviewed research worldwide about the topics of computational design and digital fabrication. As a tenured professor and designer, Mr. Vermillion offers a unique insight into the world of digital design practices, research, and his approach to teaching. And we are super excited to be hosting Joshua and are thrilled to explore more about the digital design can make buildings better members of society. With that, it is our privilege to welcome Joshua to the show and learn more about what inspires him in architecture and digital design. So thanks for joining, Joshua. We're really excited to have you a part of this little podcast.
Thanks, Stephen. Yeah. Thanks, everyone. So fantastic. I love the title of this podcast, actually. I think that's really important. It underscores what we do and who we're serving, which is humans, right? And our globe. And so, it's important to me. And it's really easy to lose sight of that. As an educator, our students even, they get bogged down in the weeds of every little assignment, and to remind them that the responsibility that they have. Once they get out of school and start to practice, is just incredible, right? It sort of lightens up the room and changes the whole atmosphere. Thanks for having me.
No, and that's awesome stuff, good stuff. I think we as people in the building industry, we can lose sight of the impact that we actually can make long-term. A lot of what we design will be around for 20, 30 years. So it's important that that is thought of.
Yeah, absolutely.
So tell us a little bit about your background, early days as a junior associate. I know you worked in industry for a while. Kind of just give us a general overview.
Sure. So I did what a lot of folks in my cohort did. At the time, I went and got my 5-year BArch degree, and then went on in the workforce and worked for a few years. But I had these questions in my head, and that's basically what sort of brought me back to grad school, was to sort of really try to wrap my head around certain questions dealing with technology and how they begin to transform our industries. And so the question I really sort of started off with is how much of this is disruptive and how much of it can just augment the things that we do. And so I was fascinated by all of these sort of really fancy computer renderings, right? These visuals that would be spit out really quickly. And I thought there's got to be something more to it than just this, the sort of technology side of things with our disciplines. And so I went back to school, and I learned all about how, certain industries, I'll give an example, the steel industry, for instance, has been, integrating digital automation for a long time, right? The digital information that they receive and produce, it drives every small detail from how something is well detailed, and then how it's made, and then how it's shipped to site with all the logistics, and then how it's put together on site. And so, that was a mind blowing discovery for me. I when I went to school, I started with a T-square and a parallel bar and all of this sort of manual drafting equipment. When I started to do my thesis project for right before I graduated, I was writing things in DOS and letting the computer sort of render things out for me and sort of pushing digital data around and so coming of age in that time, I think was a pretty interesting. A lot of questions came out of that, and so that's what I've been sort of fascinated with and working on, and that brought me back to academia. Once I stepped out, I came back.
So you really saw what was going on in the in another industry, right? I mean, the steel industry, and how they were actually detailing out the actual beams being brought on site and how they could actually fit together in more of a Lego format, if you will, right? How they could all be bolted together and how that actually came together in the grand scheme of things.
Right. I mean, they I think early on they saw digital technology as a way to sort of simulate everything, to decrease the number of errors, to optimize things, to cut costs without maybe cutting quality, right? And so, I think as a building industry, there's so many folks, there's so many industries involved under one big umbrella. I think we can learn from each other and see, some industries are farther ahead than others, I guess you might say, right? So the sharing of information, digital information, is becoming more and more prevalent, right? But for a while, it was actually a really big legal issue, right? So it's those sorts of things that I think are really interesting. But I'm always been really just interested in making things, and so I don't know. Your viewers won't be able to see this, but behind me in my office, I'm surrounded by all of these models, and some of them are, put together by hand with X-Acto knives, and a lot of them are 3D printed or laser cut or sculpted with digital fabrication tools. But this idea of taking the digital technology and actually letting it help us get closer to questions of performance, questions of production, questions of materials, I think is really interesting. And it's hard to sort of scale those up in a broad way or in a big way in school, but we can do it in certain targeted and strategic ways here in the academy, just to sort of get students to really start to think about that, right? So yeah, anyway, I've been fascinated by sort of using this digital technology to sort of get us closer actually to atoms, right? So bits to atoms, I think, is the key thing here. It's not that we can just make a model quicker or more efficiently at the very end of a design process, but that this enables us to continue to make and speed up that process, that feedback loop between making and then going back to and redesigning or optimizing or changing things and then making, right, as a means of simulating our design ideas.
So I have a couple of questions that popped out here. We'll just see how this flows. So, all right, sure. Hand drawing, right? I started out hand drawing too, right? Doing drafting, old school table, right? T-square and all that. And there was a lot of fun in that, right? And there's a lot of craft, if you will, in making a drawing look the way it does, right? I mean, it was almost like you were doing artwork at that point. Even in just, engineering drafting, it still was almost like a piece of art that you were generating. It all had to follow certain guidelines, but it looked, there was a whole craft around hand drawing, right?
Absolutely.
That we've lost with the digital age, right? I mean, if you look at a Revit drawing and you look at what a hand drawing is, they're worlds apart, right? On exactly how we do those drawings. And all for the better. We can turn out drawings so much faster than we can by hand drawings. But what's your take from, hand drawings is kind of takes a little bit of time to do, and there's a little bit of thought that you can put into when you're actually drawing. You can, if you will, let your mind wander a little bit in your design that you're working on, where digitally you don't get it, but you can iterate faster through digital. What's your take on, having X-Acto knife models versus actually 3D printed models?
Right. Well, that's a fascinating question. Yeah, absolutely. So when it comes to teaching, I mean, I'm in all of the above sort of approach, right? I feel like the tools change and evolve, right? But at the same time, the sort of rigor involved doesn't. So the level of thinking involved in the critical use of media, right? Whether that's a pencil and paper, whether that's a pen in our sketchbook or a cocktail napkin in the restaurant when a good idea strikes us, or whether that's a computer mouse and a mouse pad and a laptop. I still feel like, there's certain things that never change, right? And so I feel like that craft is what I'm trying to sort of strive for with the digital technologies. Um, you know, what's interesting about this is that, honestly, it's sometimes it's a lot easier to sort of, especially when you're starting out, to just sketch, right? In fact, the digital media courses I teach, where we talk about BIM and parametric thinking, oftentimes we start with sketches, right? So we start to think about geometry. We start to think about, which is ages old, right? We talk about the history of a word like spline or lofting, right? Which are in for those who don't know, in CAD terms, those are ways to generate curves and lines and surfaces. But they come from the shipbuilding industry from thousands of years ago, or the stone carving industry from thousands of years ago or hundreds of years ago. And so there's this rich history when you look under the hood of how we begin to make things, right? And so thinking about that, even something as simple as drawing a picture of something, but then thinking about how it could be, pieces of it could be made in a factory and then put on a truck and shipped on the highway, right? As soon as you start to talk about what happens after they make the drawing, certain things sort of their eyes sparkle. My students, right? They start to say, "Oh, yeah, right." And so, we actually are fortunate here at UNLV in Las Vegas to have a really great relationship with our professional community and with the AIA, for instance. And, I have a great set of colleagues. Some of them are always taking students out to construction sites, right? There's lots of construction going on. We just got a new football stadium. We have a Death Star looking globe, sort of new construction going on just down the road from the new football stadium. And so, in a place that's constantly changing and constantly building, constantly in flux and evolving like Las Vegas, it's actually a pretty interesting laboratory to sort of learn how things go together. And to sort of hear all these competing constraints from all the different people involved, engineers, architects, and general contractors, right? So it's really interesting when you can get all three of them together and start to hear the sort of larger story. There's sort of an ecosystem of stories on how you sort of make things align, right? That's always the hardest part. How do you make things align but make them look like they were supposed to align at the very end? So when it comes to the sketching, what's interesting about this is, I still have my Moleskine sketchbook, and I usually have a pen clipped right here at all times. And but what's interesting about this is, over the summertime, something fairly new just sort of exploded on the scene. It's this artificial intelligence text-to-image diffusion models, where you can start to write a description of something, and then a diffusion model, the bot on the other end, pumps out a picture based on your language. And so it's absolutely fascinating, right? Like I start to, in my free time, like I'm grocery shopping and I have to stop and pause. I get an idea. Normally I would think about writing something down or scratching it down on a napkin if I have my pen. Now I type out a description on my phone, and then 5 minutes later I come back, and there's a set of images as the AI bot has sort of reinterpreted what I've tried to describe and visualized it. It's sort of like augmenting that sketchbook. It's not going to get rid of the sketch, and it doesn't pull out like something fully formed. Like if I say I want a large cathedral space made out of steel and glass, and I start to give it all these descriptive words. It doesn't actually give me a design that you can build, but it is sort of a fascinating way to sort of take your ideas and just quickly pump out images of it. And what I think is really fascinating is that just like when we start to sketch, we never have the idea fully formed in our head. We sketch to develop the idea, to continue to ideate, right? What's I think more fascinating from these AI sketches, I would call them, is that when it does something unexpected and pops up something that you wouldn't expect and gets you to think about your problem or your idea in a completely new way, it sort of tickles the imagination. And so it's sort of an interesting give and take where instead of just sort of directing the computer, the artificial intelligence in this case, the diffusion model, is sort of more of an interlocutor. You're having a conversation with it, But it's more of a conversation that you might have with maybe like a 7-year-old child or something, where it takes certain things literally when you didn't mean things literally. And so having that conversation, I think, is a sort of fascinating way to sort of understand how this faux neural network thinks, and you're sort of mining it for ideas or visuals. And so, it's again, it's just something that popped up on the scene this summer, and I've been going back and forth with this, and it's been really sort of popular. I sort of post the results on social media, on my Instagram, for instance, and I get like hundreds or thousands of likes, like really quick. People going, "Wow, that's absolutely fascinating." I go, "Well, I kind of dreamed it up, but I didn't really generate it, right?" And so it's this really interesting way of sort of thinking about digital technology. And the question is, again, how does it augment the things that we do, right? I think artificial intelligence, just that word alone, is really sort of fascinating, because I wouldn't really say that a diffusion model is intelligent, right? But I had an interesting conversation once with somebody in psychology, and the question was, well, are these systems creative? And so, I actually brought that question into my students, and we started to talk about, well, what is creativity, right? Again, it's really simple idea that you would think, or really question, or a word like creativity, you would think that, we would all know what creativity is. But when you ask questions about it and sort of try to define it, it gets a little fuzzier, right? There's some gray areas there. And it sort of begins to sort of talk about, well, how can technology and humans work together, right? And how can these things be maybe augment what we do? That artificial intelligence is a long way off from replacing us, for sure. But at the same time, I think it's interesting to sort of think about how it shouldn't just be a computer science question, how we use these tools. Designers, architects, engineers, we need to be at the table, sort of looking at how these things work, how they might actually help us with our workflows. And there's all kinds of ethical questions as well, right? As things get started.
So kind of just thinking about, like, if you were to throw a first draft, right, at the bot.
Yeah.
You kick something back and you're like, well, there's a little too much yellow in that space, or whatever it is, right? And you're like, well, okay, what if I were to re-describe it, a little this, a little that, and see what it kicks back again, right? And play it back and forth and iterate, just to kind of say exactly, just by describing something slightly different, how does the next iteration look?
Yeah, these written descriptions are called prompts. And now there's this whole sort of crafting of the prompts, right? Like it's like you're wordsmithing, right? It's like you're trying to sort of really elaborate on the language, like what descriptive words really work. Do you say house? Do you say home? Do you say villa, right? All of these sort of words have connotations to it. And the way these diffusion models are trained, with, billions of images with metadata attached, right? You start to really think about the words that you use. The reason I brought this up is because me and a colleague who are teaching design studio, we wanted our students to write better and to have maybe an easier time in writing about their ideas and their goals for the project. And so this became a way to get them to iterate their writing with a sort of immediate payback of sort of seeing what the computer produced is based on the description. And so it was a way to sort of get them to continue to elaborate further, right? Ultimately, I wasn't really interested even in the results, the images popping back at them, but really about those prompts. And again, you can go back and forth with the bot really describing it. It's almost like a chat. As you start to, change the order of words or their prominence, or change the words that you use, right? If you, let's say, for instance, you give an example. If I say, I want to really large oranges rolling down the street, and it might say, well, was that like the fruit orange, or was that the color orange? And it might give me lots of other kinds of fruit rolling down the street that are all colored orange, right? So it's these sort of things that you really have to sort of think about, step back and say, well, how do I say things succinctly, but how can I be also at the same time more descriptive? Like, so you have a limited number of characters you can use, but within that you have to be strategic. And what do you really say? I think that's a really interesting question to ask yourself. And so, the idea of how do you make your ideas, and how do you describe them, and how are you more persuasive, I think is the how, the lesson I want to sort of relate back to the students, So anyway, it's really sort of interesting. And if anybody's interested in seeing the results, feel free to stop by my Instagram account. There's lots of results there.
Yeah, it'd be cool to see kind of what you're thinking about and how you're getting more refined in describing what you want to describe, right?
Yeah, I actually have an example if you want to hear of a prompt.
Sure. Yeah, let's hear it.
Sure. So here's an example prompt. I'll start now. A stunning interior of a split-level villa, intricately stacked and iteratively interlocked stone blocks in the style of the Enos House. Extremely coherent, a fusion of Frank Lloyd Wright and Carlos Scarpa. People are sitting at a table eating dinner, plants and moss and ivy growing on the stones, pools of water, indoor picture, long shot, architectural photography. So a lot of those clauses are strung together with commas. And, what you'll hear are a description of the subject, then some details, and then further sort of talking about the atmospherics or the media, trying to evoke, let's say, architectural photography or watercolor or, whatever it is, right? So it actually has quite a broad range. And then the results that it spits out at you, you can start to, again, expand that design space by, retyping language. It's a really interesting rabbit hole to sort of fall through as you start to play around with the technology.
Yeah, and as you were saying that, right, I could actually kind of picture what the building looked like in my mind, and so
Absolutely.
It'd be very interesting to see what the computer did right now, what my mind was interpreting. And if you think about sitting with the client and kind of describing a space to a client in the picture that's being painted in their mind and what's in your mind, and then the computer doing that, generating that first pass of saying this is what it looks like, that actually be a pretty interesting design process with the client. Oh, that's not even what I was thinking, right? And you'd be like, oh, okay, you know what I mean? That's just very quickly iterative to get to a place to say, what style are you looking for whatever it is you're designing.
Right. And suddenly it comes back and, maybe instead of granite or, marble that you had in mind, it comes back with red sandstone. You go, I never thought of that. Now I'm going to type in red sandstone and see what happens, right? Or whatever it is, right? So, all of these sorts of things are kind of interesting. But I think, again, that what I always come back to is how these things begin to either augment what we do in the process of designing engineering, or how does it enhance or augment our experience spatially when we're using a building, right? Another thing I've been really interested in and used to create these sort of spatial installations with students where we do design build installations, is how to embed robotics and sensing into architecture. So the idea of how do you start to make our environments smarter in a way, right? Maybe they can react, or maybe they're just sensing. But the idea is, how do you make something spatial that begins to be more empathetic to humans walking through or reacting to it, right? And so, as an example, we did a number of sort of hanging installations that you would walk through, and there were IR sensors embedded within it, and so things would start to shake and move or change their lighting configurations based on folks walking through it, or moving their hands closer to it or further away. And so, just sort of thinking about, again, as our built environments, how do I say this? As technology gets embedded with more and more within our built environment. So if you think about our houses, right? For a while, really the sort of only sensing that we had was maybe our thermostats, right? It'd measure temperature and it would kick on, the air conditioning or the heater or whatever, right? Now suddenly, like, a lot of the stuff that we plug into our walls are connected to this Internet of Things. Our televisions, our voice assistants, even our refrigerators and stoves now, and toasters and coffee makers are in some ways smarter than they were 5 or 10 years ago. And so, asking ourselves, well, if this phenomenon continues and our houses, our homes, our buildings begin to get smarter, shouldn't we be a part of that conversation? It shouldn't just be a Google question or a question for Apple, or architects and engineers and all of these professionals from the building industry should be at the table, sort of thinking about and shaping how this might happen, right?
So we're working on a new project here, new residents, and we're working on some beta windows. And so the windows are going to be smart windows, right? They can open and close to ventilate a space. And the question comes back, how do you, all right, so you don't want to be cooling a space that the window's open or heating a space with the window open, because we want to get natural ventilation going through that space, but it's all going to be automated. So that has to integrate with the HVAC system we're designing. And what does that interface look like? Just technology wise, is there a common language that they can both speak that we can make it happen? But yeah, that's exactly where we're kind of headed. Windows opening and closing, and how does that interface with the HVAC? It seems pretty basic, but it's kind of difficult to do right now, right? It's the technology is kind of there, but it's it still needs to be formulated out. Think about moving walls in that space, right? I mean, that's a totally different. We have so many flex spaces that are designed with walls that have to be manually moved. But just think if you were just to say, okay, let's have a large all hands meeting and desk and things move, and you just have a big common space right there as the people just congregate. Yeah, it's pretty interesting.
Yeah, it's fascinating, right? And so, and what you mentioned just now, there's a big chasm, I think, between the hypothetical, it's all digital information and it should be easy, and then the Apple model of it just works. You know what I mean? Right? So there's nothing, you have to sort of build the bridge. It's like flying the airplane and you're still bolting the wings on, right?
Right.
If that's what it feels like, I think. And so that's why I think the universities can sort of step in and study this stuff, right? Help out where we can. Where it's not that we're going to be, producing these things, but trying to sort of figure out, well, for instance, where can we begin to target these things, right? Like when it comes from a market perspective, right? What makes the most sense? When it comes from a cost perspective, what makes the most sense? When it comes from an energy use perspective, what might make the most sense, right? Those are sorts of things that we could write grants for in the universities to study, to measure, to produce white papers so industry can use that information and respond to it. And I think, to me, that's sort of the fascinating thing here is, well, now that we can do anything, what do we really do? How do we do it? That's the other question, right? I think the industry needs data in order to sort of better understand, well, if we invest money into this, how do we do it in a way that'll pay out, right? So anyway, I think that's a really always been an interesting question. But more so as we walk through cities now and the buses that drive by us are collecting information, right? There's weather stations at bus stops throughout downtown Las Vegas. They're collecting information. What's interesting is now all the surveillance cameras in downtown Las Vegas are using AI algorithms to sort of understand where people are, traffic patterns, where trash is blowing around, all these sort of things, right? There's things where municipalities now have digital twins, right? The sort of data models and virtual models of the cities themselves that sort of are trying to display and simulate the information in real time, the sort of digital equivalent of the real version. So it's a really interesting way. Municipalities are really interested in this stuff too, right? But they're stewards of where do we invest money and how do we make our cities better, right? And so again, I think that's another way universities can really start to play a role in studying these things to give more data to the folks that make decisions.
Well, yeah, I mean, as you're talking about this, I had two things that really popped up into my mind. And, you talked about like the buses and everything getting data. And I was talking with another architect yesterday and, more walkable and bikeable spaces, right? But then there's also the traffic flow that needs to happen as well. So maybe if there was a model that at certain points, this space is a walkable, bikeable area. But then, due to traffic, everybody's leaving work or whatever, there's a model where, okay, now it's a drivable space, right? And there's we were talking about certain places here in the Denver metro area where it was like, why isn't that walkable and just strictly bikeable? But it messes up traffic patterns. And they tried something in Boulder and it failed, because traffic patterns. Yep. But I think if it just even that, right? I mean, and how much difference do you change a space throughout a day on how people are actually using it? Is it easier for them to walk across the street to go to lunch, or do they have to get in a car to drive to go to lunch, right? I mean, there's a big difference in just how a community can be used in that. So that's a totally different way of thinking about how we could actually use a city. So
yeah, it's fascinating, right? I mean, I remember a long time ago watching a film, maybe it was William White or somebody that was looking at how the Seagram's Building Plaza in Manhattan was used back in the 60s or 70s. Completely different than today, right? So there was lots of people eating lunch, congregating in small groups and cliques, and then, sort of looking out, everybody talking and having a great time. And now I think everybody just sort of is like staring at their phones, their smartphones, as they walk through, or maybe they stop to take a phone call or to tap something out with their thumbs. But yeah, absolutely. And in a place like, where I'm from in Las Vegas too, right? That streetscape becomes so important. So, for instance, overlaying weather data, right? So how hot do our sidewalks get? In some of these summer months, right? Becomes another question when it comes to making our downtown cores, for instance, more walkable, right? More livable. And that's a really huge question post-pandemic, right? As you start to, I think everybody's questioning now, do we keep real estate in urban cores, or do we, and what's the role of a central office, right? In maybe a new landscape of folks working partly at home and partly at the office, right? So, that's always a question, right? Where do the food trucks park? How do we reconfigure sidewalks? The big question now is how does our infrastructure respond to changes? It seems like the automobile industry is right at a moment where things are really starting to shift quickly. And so, to me, that has big implications on all of our Western cities in particular that grew up with the automobile, right? So I think Denver and onwards, west, Phoenix in the Southwest, Las Vegas, Salt Lake City, up, north of us, and of course, California, and, all these cities that grew up with the automobile, it starts to make you wonder how that's going to change the morphology of our cities and how we use them.
Yeah, Seth Godin, in one of his podcasts, he mentioned that, a city, if you think about it, has an operating system because it's the way the roads are laid out and the way the buildings are laid out. But if you can actually change the way the streets are used, you can kind of change the operating system of the city, right? I mean, you can actually change how that city is used in a crazy way. Even though the physical infrastructure there, but the use may change and how we, during the pandemic, right? All of a sudden,
absolutely,
people could put their restaurants in the street. They would block off
pop-up
streets.
Restaurants.
Yeah, exactly. Yeah. Right.
Or empty streets that became cycling. You don't have to wear a mask if you're outside, right? So suddenly I could bicycle down Michigan Avenue in Chicago or Las Vegas Boulevard, the Las Vegas Strip.
Yeah. No, that's all just really cool stuff, man. That's all kind of jacked up about it. It's exciting stuff to hear how we can just change, even buildings. I'm sitting in the office today. Most people are working home today. That's kind of just the way COVID is done. And we were kind of that way before. But, right, how could you change this space to be something else that, maybe the lady downstairs that teaches Tai Chi, the space could change quickly and she could offer another class when we're not using the space on Friday afternoons or what have you, right? I mean, how can you make these spaces change? And you can actually change the use of a building and, she can get more business. We don't need the space. It's just, there's a lot to do with being able to change spaces quickly and how that happens. I think there's a big future to that. So yeah, it's great that people are actually thinking about how that happens. Yeah,
absolutely. And, the other thing is, how much energy is the building using, right? So, for instance, if the new model is, certain parts of the building are empty, certain times of the day, and now we're all looking at our houses, we all figured out what exactly works in our houses and what doesn't, right? Like our domestic spaces have largely not changed too much over a long period of time, and now suddenly I think there's a lot of questions and being asked about, well, what do we really need in an apartment or a condo when we can't really leave it, right? So, all of those sort of questions I think are sort of up for discussion now as we start to rethink things, right? But, our houses were, the lights were on all day, right? Instead of, being out from, 8 to 5 when we're out at work or whatever. And so, these sorts of ways of sort of thinking about the city as a how do I say this?
How does the city change throughout the day, right? How does it serve from being maybe a place of commerce during the day and to a place of entertainment at night, right? And not have to change locations.
Yeah, absolutely.
So what's the biggest challenge facing your work right now, teaching and working with young people?
That's a great question. So yeah, I mean, there's several things. I think one is, it's this sort of speed that, as we work more and more with the computer, with digital technologies, there is a sort of time where I'll say, actually, let's slow down and let's stop for a moment and let's really look and see what's going on here, right? So, for instance, we'll be thinking about or talking about, let's say, a workflow, and through some software to try to, model something and virtually in my digital media course, right? And so I'm training future architects. And so, we'll take an idea, then we'll start to give shape to it with surface and planes and, sort of manipulating virtual geometry around the computer screen. And then something will happen. They'll say, well, this is taking longer than I expected. And I'll go like, well, how long did it take? And they'll say 10 minutes. And I'll say, that's not long at all. In fact, I'll remind them that, 10, 15, 20 years ago, when I was doing this as a student, that same task, would take the computer about 48 hours, and I would lock the computer down and leave and live the rest of my life and do other homework and things like that. And then just keep checking on the computer and to making sure that it didn't crash and then getting the results. And so I think the acceleration is kind of an interesting problem that I see, and that they don't understand how good they have it sometimes. And so it's like, again, what I go back to is something I mentioned maybe at the beginning of the discussion here, and that is, the speed that these technologies afford us isn't just to take a shortcut, but that maybe we can actually do things better because it allows us to really, I think, look at the problem over and over again and begin that sort of feedback loop where we can begin to optimize and integrate systems in ways that really, I think, can help, let's say, architects work better with engineers. Architects and engineers work better with the folks downstream that make the stuff and assemble the stuff, right? And so, to me, in particular, the building industry, I mean, we're all sort of these fragmented professions and disciplines and industries, and we all come together around these one-off projects from time to time, and somehow it works. Yeah, usually anyway. But that's the interesting thing. So to me, how these things actually help us, how serious people solve serious problems. It's not necessarily just taking a shortcut and doing it the same way we did, but maybe, in a tenth of the time. It's, with the time that we have, how do we make these things better, right? And so, I think that the technologies help us measure things better. They help us see things better. They help us see potential problems better. If building a physical model helps, right? To me, early on when I started, studying architecture, we had to think three-dimensionally. You probably had this problem too, through two-dimensional drawings, right? Except for when we had to build models, right? And so building models is like the way of thinking three-dimensionally about three-dimensional problems, right? And so, the computer helps us, look at things three-dimensionally. But at the end of the day, I still tell my students, you're trying to do something here, make it. If you can make it, I believe then that, we can start to really wrap our heads around the problems that I see here, and here, right? It's how this thing meets the ground. It's, the slope. It's where the roof and how do you turn that corner. All of those problems, all those things that we've always talked about as architects and engineers. The question is, well, do these tools actually help us do them better, or do something that we haven't done before, or allow us to understand them better and see things in a way that helps, when the custom curtain wall is mocked up and they throw water at it and wind at it and measure its performance, right? To me, it's those sort of questions that I think I want my students to really think about, right? It's not about a shortcut. And I'm always sort of battling that, right? They always see these things as shortcuts, and it's like some things you just can't shortcut.
Right, for sure. I mean, take the extra time and think about the next level of it, right? Yeah. Since you just created the time. Yeah.
Absolutely. Right.
Yeah.
That created time is better used, to make things better. Right. I mean,
Yeah.
that's, we're always working up against time, right?
Yeah.
You'll never have more time.
Yeah. It's
So,
how you use it, right? That's all time management. Yeah, exactly.
absolutely.
So what do most people misunderstand about architecture and digital design and how that interface comes together?
Yeah. So a lot of folks think that, digital design is all about just producing pretty pictures. And there's a lot of that. But like I said, there's an ever expanding sort of space of research and real world sort of applications of integrating technology in the design of making our built environment, into the built environment itself, how we make, things. So it's like, sorry, maybe I'll back up. It's not just about producing pretty pictures, but it's about maybe transforming how we design the built environment, how we make it, how we construct it, and then how we use it, and how the built environment can sense and have technology integrated inside of it. So, to me, I think there's a lot of different directions to this, and the changes are happening really fast, almost on a day-to-day basis. Like I said, I mean, now I can, on my smartphone, I can sort of see people driving by my house through the security camera that's mounted, and my coffee maker tells me when it's time to get up, and it's already brewing coffee for me, and those sorts of things are crazy. But the question is, I think, what can we expect? How can we expect architecture to change? Right, not just our appliances, not just our the devices that we plug into the wall or carry with us in our pockets. So, to me, I think that's the question.
I have you talk a little bit about co-founding iMade and what that is.
Yeah. So back when I came out of grad school and I got my first teaching job back in the Midwest in Indiana, the Midwest is still a place where there's a lot of industry, still manufacturing, not as much as there used to be, right? But there's still some active industries there. I think, in terms of Indiana limestone, the hardwood industry is still there. That they harvest both trees and lumber, but then they're also making things like furniture and things like that there out of hardwood. There's still part of the steel industry in the northern part of the state. That's part of the sort of Rust Belt along the sort of Great Lakes area from Buffalo all the way down to Chicago. And so, part of what we try to do was to create an institute with grant money that could sort of bring together students who are there to learn, and researchers and academics and industry, to sort of think about these problems. And so what we would do is we would visit industry. We'd listen to the problems that they would have. We would, they wanted to continue to ramp up how they begin to integrate technology to make things better, to make things faster, to make things less expensive. But those are big investments, and to sort of understand, well, how can they do that in targeted ways. So it was ways in which we could begin to do some R&D for industry, right? And at the time, sort of bring together a broad range of people to look at these problems. Our students learned a lot from doing those sorts of things. They would, for instance, what we call immersive learning. Our students would then get to visit and network with folks in the building industry, looking at problems, and then the building industry might, let's say, the limestone industry might give us machine time and labor and materials. Then to design something, but then to try to test out that workflow, from using digital design information all the way to their production equipment, right? And so we did that with the hardwood industry. We did that with the limestone industry. We did that with the steel industry, looking at different ways to sort of make stuff and to incorporate R&D with industry along with education with students in a sort of win-win relationship is really sort of an interesting model. And the students that came out of that program, they're doing amazing things now. They're, a lot of them are in leadership positions now in their respective firms or companies. Um, but the work they did was amazing, right? So we would have these digital models, and we would have this sort of screen capture of the BIM model, and then we'd have the photograph of the actual thing, and they were like one to one. The relationship was just, it was uncanny, right? As we would have these really interesting conversations with folks, the production people, the folks assembling things, and we were all speaking the same language because we all were looking at the same information, really. And it didn't have to pass through the filter of all of these, paper drawings translated into section and plan. So we were all looking at things three-dimensionally in the same virtual model. So it was a really, I think, kind of an interesting way to sort of think about, what this stuff might look like in the future more and more. As the sort of digital model, the digital information becomes a sort of database that everybody sort of draws from and feeds into.
So with that, there's some conversations that keep, we have and they're big a lot in the industry about offsite manufacturing, right? Modular construction. Maybe we make wall sections offsite. Do you think architecture in the 10 years from now, do you see that being a more prevalent or less prevalent, or kind of we'll just have better ways that we ship drawings to the field and how the field actually is able to assemble it? Or do you think it's still going to be a mixed bag? I mean, if you had a crystal ball.
I think it's situational, right? So I think it's situational on place. I think it's situational on people. So for instance, I think, prefab, right? So if you think about prefab or modular housing, it's always, the promise of it has always been there, right? But it's always been largely dependent on the situation of having the right manufacturers, the right designers and engineers, the right clients, right?
And transportation.
Absolutely.
And transportation.
Zoning, community, right? I mean, all of these things, right? Somebody sees that and goes, "That's really great," and another person says, "That's not my backyard," right?
Right.
And we see that all the time in Las Vegas. So in Southern California has that problem when it comes to housing and those sorts of things. And so, those problems are prevalent everywhere. I see it as maybe a modular scalar problem as well, right? So, for instance, there's always going to be things done on site, and there's always going to be things that are done in a factory and then shipped to site, right? I think about that custom curtain wall, right? That just sort of comes in chunks and pieces and then just sort of gets erected and clipped on, right? But there was somebody out there, basically pouring all of the assembling the frame and then pouring all the slabs. That's actually a problem in itself. How accurate and how the precision of, let's say, all the on-site labor and all the off-site labor, when they match up, right? How do you begin to build in the for the irregularities, the stuff that you can't anticipate, or build in just the tolerances, right? So it's always about that tolerance problem. Anytime you do that, so the promise of prefab or offsite construction is sort of tighter tolerances. I'm kind of even pouring a foundation, right? There's a different tolerance there than there is in a factory, right? So, all of these things have to be taken with a grain of salt, I believe. And again, it comes down to serious people trying to work out the serious problems, thinking steps ahead, right? So, digital models, virtual models, the technology is there to sort of visualize and draw things to just an amazing amount of precision. But a piece of wood, a stud, something that's cast out on site, it's never accurate to 6 decimal points of accuracy, right? I mean, that's impossible. And so to me, that's always the sticking point, right? How do we reconcile those things, right? The actual materials, the actual sites, humans working out in a muddy or hot, dusty construction site, versus those, clean spaces in a manufacturing facility, right? The same thing with 3D printing. So what's interesting is that as we begin to think about robotic arms, industrial robotic arms, or other sort of 3D printing, but at a large scale, right? The question is this happening in a controlled environment, and then you ship something to site, or is this something that can be deployed, on site? And what does that mean? And how do you begin to, how does it situate itself in space with GPS technologies, and how does it go up and down hills with tire caterpillar treads and things like that? So to me, it's a fascinating space, but there's an awful lot of question marks there as you really try to deal with it as a problem. And there's this idea of co-robotics. So it's not necessarily about replacing humans on sites or in the production facility, but how do robots and humans work together, is another way of thinking about things, right? Just particularly if you think about robots that are arms, robots that are moving around, robots that can, as quadcopters can fly around in swarms even. What are the roles, and how do these things work in tandem? Again, ultimately, the question is it progress, right? Are we doing it better? Are the things that we make, do people like it better, right? Ultimately, we're designing and making things for humans, and so and other organisms, right? So, are we doing it better? Are we making the world a better place? Is always the biggest question that you're asking. So, to me, I think that's the other part of this, right? The ethics question. It's sometimes we can throw technology at things, but the larger question is: is this really progress? Is the direction we're going really something that's making things better? Or it would be terrible if at the end of this we realized we were our own worst enemies, right?
So I had another architect on the podcast, and he brought up a very interesting thing about the offsite manufacturing.
Mm-hmm.
And he was like, people that work in a factory, it's kind of, factory work isn't the most pleasant work, right? I mean, it can be very repetitive. You're kind of stuck in the same thing. And his whole thing was like, let's keep the guys on site, right? Let's outdoors, let's have them doing stuff. And he thought that, his take was having guys on site building stuff was better than having people stuck in a factory. That was his point of it. So you're right. It comes down to a little bit, what does it look like on having two different types of manufacturing going on site versus off site? What does that look like? Are people just stuck in a factory? Yeah. They may be pinned down economically, right? So there's a lot of things with that.
The economy of scales, division of labor, right? So if it's simply turning 6 bolts and then watching that go by, and the next thing comes and it's tightening the same 6 bolts in the next assembly, right? That would be a real darn shame, right? Because I have a real respect for folks that are out there, on site, outside, trying to put this stuff together, right? It'd be a real darn shame if we lost that, right? And so, there is, I did have a chance to tour manufactured housing production facilities in the northern part of Indiana, where there's a large Amish community, right? And those folks are, in a production facility, they still are a jack of all trades there. So in that case, what's interesting about that is there's the they have sort of incentive to fix problems and see problems ahead of time, because it's all based on time. So if they get it done early, they still get paid the same amount, right? And so they start to if they can rely on this sort of common sense, I would say, the sort of the their experience, right? To sort of problem solve in situ in a way that's similar to how you would when you run into a problem on site.
Yeah, and it may even be that they can see if they're building the entire structure, right? They could see all the problems because they understand, well, that framing is going to cause plumbing issues. Let's fix it now as we're framing it, versus just kicking it down the assembly line, and it gets down to the plumber. He's like, hey, I can't run my waste through here because I got a header in the way or what have you, right? So,
and the part of that is, similar to, let's say, building an automobile, right? When it comes to manufactured housing, it's like you can have this one, or you can have this one, or you can have this one. It's not like each one is a one-off proposition, but they do the R&D, they sort of figure it all out as much as possible, and so, again, a lot of what we do in the building industry isn't that. It's one-off projects each time, or close to it. Even if we have a client where they're building similar things, each site's different. Each zoning sort of situation is different. Each site has a different orientation to sun, wind, and light, and all those sorts of things, right? So, again, I think we have to take it with a grain of salt. I think smart engineers and architects are always going to try to find ways to incorporate it when they can, prefab or off-site construction when it makes sense. Maybe it's about doing something too complex to do on site, or maybe it's but I think it's always situational, right? I think it's always going to be situational to place, to people. It's just, I don't think there's a one size fits all solution there.
Yeah, and I think one of the things that in our research for the work you do at UNLV, it's the students are hands-on, right? There's a lot of hands-on that the students actually are doing there, right? There's labs for them to go work on.
Yeah. Yep.
And that's huge,
we have
right?
Full wood shop, full metal shop. We have some CNC labs full of equipment. Last spring I did a design build elective with the tile industry. So they had their international trade show here in the convention center. So they gave us all the materials. We made this large serpentine wall. It was all custom sawn tile mosaic with this gradient pattern that we made. Absolutely. It took a lot of work, but at the end, the students really sort of understood. Well, first of all, they understood the material system better, but they understood that sort of idea of every line, every curve, everything that they draw has implications downstream when it comes to making, building, assembling, and all of that stuff, right? And so, to me, I think that's a valuable lesson to learn. The sooner they can learn that, the better, because then they can build on it, right? Then they can start to they get better acquainted with using the wet saws, using a table saw to cut the substrate, looking at how to turn a corner, and looking at how to make something. Is it a rabbet joint? Is it a miter joint? Is it a butt joint? Those sorts of things, basic things, even just to get them going, right? Anything to get them to sort of think about those details, really important, right? I think that's where really good architecture happens. Is you can have a great idea, but if it's not executed well, it was only a great idea, right?
Yeah, I think so when I got my undergraduate degree, I worked as a carpenter for 5 years, and
Yep.
Here I am, a mechanical engineer. I'm like, why am I working as a carpenter? Now I look back on that, I go, that was the best experience I ever had, right?
Yeah.
So now I really favor that experience. And a lot of the ways that education is structured and the way tradespeople are, at the trade schools and all this, there's not a lot of apprenticeships that happen, right? Where you can actually work your way up and through all the way, like start out as a low level, carpenter or whatever, and then work your way up actually into an architecture part. So you have to have those mediums that you can actually get out there and you put it together and see exactly how it happens. It's because what happens digitally, in the digital world, and actually how that gets implemented, there's a big difference, right? There's a lot that has to go into that.
One of the most productive summers I ever had was when I worked on a framing crew, right? And then suddenly, when I went back to school that next semester, I had to draw a wall section. I was like, oh, yeah, like that goes here, and this is why, right? Like that was the most fascinating thing. Is like, this is where the drip edge goes because, right? This is where the flashing goes because, right? This is where this is how this is what we look at when we're putting a window in because, right? So those sorts of things become so important. You don't really even necessarily realize it at the time when you're learning these things. But then when it comes back, you're trying to draw, you're trying to sort of figure it out. It's just, oh, I see now. This is how you put that plate onto the concrete. This is how you, flash that windowsill. This is how you, put the coping around the parapet, right? And how it meets with the roof. And, that kind of stuff is so important. it doesn't maybe get the as much emphasis as it should in schools. But that's stuff's really important. I live in a place where just about every building leaks. The 3 days of the year that we actually get rain, we find out exactly how much we didn't really take into account rain, right? And the building culture here doesn't really have to worry about it too much because, you don't have to worry about it 3 days of the year or whatever it is, during our monsoon season when we get rain. But we have a lot of leaky roofs.
And it dries out really quick, right?
It dries out really quick. Yeah, it sure does.
It's not a big deal. So, tell us a little bit about the Bottom Up Social Change Symposium that you were a part of.
Oh, yeah, that's a great question. So, one of the things I was tasked to do through ACSA and AIA, and I had a great partner in this from the University of Washington, Elizabeth Golden, and folks from the AIA National and ACSA National were working with us. But we put together a symposium the last time the national AIA National meeting was here in Las Vegas a couple of years ago, 2019 now. Seems like ages ago. That was a pandemic ago.
Yeah.
It seemed like it was a decade ago. It wasn't. It was just a few years ago, in 2019. And so we came up with the theme Bottom Up Social Change, sort of thinking about, there's a lot of problems. There's a lot of problems. Maybe not thinking about how we try to tackle them through these big programs with these, big top-down solutions, but how folks are trying to sort of think about more catalytic ways to sort of address these things. And so, the sort of bottom up became a sort of theme. And we had some absolutely fantastic contributions to this. We put out a call for papers and projects. We got about 150 of them. We chose only 8 of them, right? So we had, we picked the 8 very best. And so we had folks in Arizona looking at how water infrastructure in Arizona, like in Tucson, could then become better designed, right? Right now, they're sort of designed for channeling the water just to try to prevent floods, but they sort of direct the water away, and so you get really ugly infrastructure, hard infrastructure that's only useful for the 3 times again of the year where they get floods. And then is just sort of sitting there useless the rest of the year. But sort of thinking about how you could think about resiliency in a way that begins to direct rainwater, but then also not just to flush it away, but to begin to store it. And then also for the other, let's say, 340 days of the year that are just sitting there could become, soft infrastructure that could be used for recreation, parks, trails, those sorts of things. Really important. You could also begin to think about bird sanctuaries and other sort. These sorts of corridors and places, spots where for migratory birds and other sort of animals to live. So it's not even just about humans, but thinking about our sort of larger our spot in a sort of really much larger, complex ecosystem. We had folks doing community-based projects and design-build projects at universities, but thinking about how things like mailboxes in rural areas could become more than just about receiving and taking mail, but could become about relaying information, collecting data. We had folks dealing with housing at a number of different scales. Again, huge problem all over the place. That our housing is expensive and there doesn't seem to be enough of it. I think particularly out along the West Coast, we had somebody from Seattle. We had folks from Southern California. We had Angie Brooks from Brooks Scarpa in LA, for instance. We had somebody from Detroit. We had, all these folks, really talented people sort of looking at these problems from a variety of standpoints, but always from the bottom up. I think it was kind of interesting to sort of think about that. How can we do small things that lead to larger things that can then get momentum? How do we think catalytically? How do we think in terms of small investments that then start to make a difference as they begin to sort of accumulate? Rather than thinking about always just these really expensive, massive top-down sort of efforts that sometimes that we do, right? So, the bottom up became this sort of way to sort of frame how each of us can maybe make a difference in our own way, right? Based off of our expertise and our interests and, what we were prepared to do, right? In our professional lives and in our volunteer lives, right? So, anyway, that was the idea behind it. And it was great. We came out with a book and everything, about it as well. And so, yeah, but I'm always sort of thinking about, um, how it's really easy to say, like, we can just create a big program and throw lots of money at things. It's maybe different to sort of say, well, here's how somebody's doing it here on the ground every day, right? Day in and day out. And it's not a huge undertaking. It's not a huge endeavor. It's not costing a lot of money, but it's making a difference. And here's how, right? So anyway, that's kind of the stuff that we wanted to highlight. Thought it was pretty interesting.
Yeah,
We
that's
got
very.
we had hundreds of people come to the presentations at the AIA convention. So, we thought it was a pretty nice success. And yeah.
What's the one thing you wish, somebody that's getting ready to design maybe a new master plan or a new building? What do you wish they would take into consideration that they typically don't when they start in on the design?
Ooh, that's a big question. Yeah. Well, I mean, I could speak to some of the things that I see out in the built environment here in Las Vegas, right?
Okay.
There's an awful lot of disregard for sun, wind, and light, right? And that's so important here in the Mojave Desert, for instance, right? So, it's easy for me to say because I don't have, I'm not a developer. I'm not investing millions, sometimes of dollars into things. But to me, I think we need to be much more careful in how we think about even the simplest moves that we make in relationship to that sun orientation, in relation to the landscape, in relation to, things like that, sun, wind, and light. I mean, it makes such a huge difference here. I mean, I do a lot of hiking outdoors. And what I've always been fascinated by is this idea of calling something a desert, thinking that it's empty, and it's not. It's not. It's full of interesting flora and fauna. But what sticks out to me about the things that grow here is just how lean and mean they have to be in order to survive and sometimes thrive here. And what that begins to suggest is that there is a way of doing it. And it's maybe not the way that we're doing it as humans now. We have come a long way. Las Vegas is leading the way. I would say one of the municipalities really leading the way in the Southwest as far as how we're using water, how we're trying to use less water, how we're trying to recycle water in a number of different ways. So, I will say that we're kind of a model, at least in the Southwest United States, for how to begin to do this. One thing that helps is that we don't have a lot of agriculture here. In Arizona, they have a lot of agriculture. Of course, in California, they have a ton of agriculture, and that's what's using up a lot of the water. But to me, it's that simple, right? When it comes to place, and when I think of Mojave Desert, it's a very special, very specific place, sacred place to some people. I think it begs us to sort of really consider, be careful when it comes to heat, light, wind, the resources that we do have here. How do we use them as most effectively as we can, and how do we not just use them all up, right? How do we share it? So, to me, I think that's always been something that's you can't go out in the wilderness here and not see it, right? It's not out of sight, out of mind. As soon as I hike a mile away from my house out into the wilderness, and I can sort of see things. It helps when you get up high, right? Out in Colorado, you can get up high and sort of see just how small you are, really, as well, right? So, to me, I think that's just sort of recentering. I always do, just individually. I try to get outdoors. I try to get up high. I try to get in a place where I can't hear another single living thing. At least certainly not another human being. And then suddenly something snaps into perspective. It's a way to sort of clear my mind, refocus, recenter, reprioritize my thoughts, and how I can be as productive as I can once I get back down into the valley and, get to work again.
Yeah, and Vegas is definitely one of those places. You're right. The desert is beautiful. I mean, a lot of people don't. If you've never been to the desert, you just don't understand how much life there really is, how hardy what is there, and how pretty it really is. And then for me, when I've been into Vegas, you're right. You can get away from Vegas and you can get out and you can get high and you can look down onto the strip and you can see just how small it seems big when you drive it or walk the strip. It seems big. But when you're far away and you look at it, you can see just how small it is. And then all the vastness that's just totally around it. And then I just think that, the sun, wind, and light, just taking that into consideration on a building. I mean, it just seems so basic, but you're right. Sometimes it's not considered. And so, that's very interesting.
Yeah. And, digital technologies, that's one of the things we're dealing with, always sort of like, how do you look at these things, measure them, start to optimize and work with them. It's another, if you use the technology in the right way, it can help you with that, right? It can help you visualize these things and work with them rather than against them.
Yeah, for sure. So, what is your favorite building and why?
My favorite building? oh gosh. I always ask people this too. I have to sit or maybe think about this for just a second. My favorite building, my goodness. Favorite building I've been to or just favorite building?
Favorite building in general. Digital, it's never been built.
All right. So favorite building I've never been to, because it's impossible. I don't even get around anymore, is the Crystal Palace. So this big 19th century glass iron building, that they built in the UK. But really sort of talking about the sea change that was coming when it comes to using steel frame and glass and later on air conditioning. And, it's that sort of building that perfectly captured the zeitgeist of what was to come in the 20th century. And really sort of captured the sort of industrial revolution that was to come, or that they were in the throes in at the time. I have a sweet spot, just a real soft spot for really large, tall, grand spaces. So I would say Chartres Cathedral, that big Gothic cathedral. It's amazing. It's amazing the sounds in that, the acoustics, the lighting, the scale. It just, again, it makes you feel small. And it's I think it perfectly embodies a sort of idea of the edifice as the book, right? And, this idea of a sort of illiterate populace, that the medium is the message, that sort of building the church becomes the sort of message, I guess, at the time. I'm not a religious person, but I've just been always in awe of these sort of really grand spaces, these big spaces, no matter the religion. It seems like for a long time, that was always the sort of doing of the church or government, or, that there was never a separation between the two. And so I'm just a nut, a sucker for those big spaces. I like museums too, and libraries, and, all those sorts of things. But that's one of those things I'll never forget, going to see that.
As we think about creating better buildings, you mentioned the new AI technology, but what's the biggest lesson, or what have you learned in the last year about, that we can do to make buildings better and that you've passed on to your students?
Yeah, I would probably come back to some of the design build stuff I've done with students. And, this last spring was an example of that. Again, working with industry, talking to the folks that make stuff, beginning to sort of understand that feedback loop between the materials and material systems, and how that can begin to really, I think, better inform all those design decisions that we make. I think there's also a healthy sort of respect and empathy that you sort of develop when you talk to others, right? I think sometimes there's a lack of respect when let's say the dialogue between, let's say, an architect and a builder, or an engineer and some whatever it is, right? I think just understanding each other better, and coming from it where it's not you can come to somebody with a degree of both empathy and understanding, but also maybe humbleness to sort of understand, well, this is what I do really well, but I understand this is what you do really well. And when it comes to talking about this stuff with you, I'm here to listen. Listening is something that I don't think necessarily is maybe a soft skill. Only some people can develop it. And so I think it's not something that is a part of a curriculum. but it's something that's so important. Listening, right? Being able to sort of read, to look, to see. And so listening, I think, is a huge part of that. To simply shut up and come with a sort of sense of sometimes just listen. I just listen. Don't try to cut in, just listen, right? Now, maybe at the end you say, well, here's what I heard, right? Am I on the right track here? But at the end of the day, I think there's a sort of humility that sometimes, if we all have just a little bit of humility, a little more humility than I think, and empathy, then I think maybe things could go smoother sometimes. And, we've all had those collaborations where they go great. We've all had those collaborations where they go less than great, And so I think that's one of the most valuable lessons you can learn when you have to work in teams, make stuff, work with industry. You're trying to design stuff. You have to negotiate things back and forth, right? You have to better understand things, right? It's not necessarily that's like, can we just do this? But it's like, this is the intent. Am I on the right track? You know what I mean? It's sort of how you begin to frame the conversation. You frame things differently. When you're talking to somebody that you have respect for and they become an interlocutor, a collaborator, not just somebody you're trying to dictate something to, right? So, to me, I think that's really, really important. I think, I'm always sort of the mindset you capture more flies with honey than a fly swatter, right? So, to me, it's that, right? How do you work with people rather than working against them? I mean,
Yeah, it's definitely, and especially when we're building big structures or great projects, right? It's got to, and they're complicated. I mean, buildings are getting more and more complicated.
Absolutely.
They're not getting less complicated. They're just getting more and more complicated. I mean, we're bringing, like we've been talking, bringing technology.
The expectations get higher and higher. Too,
higher
right?
and higher and higher. Yes, exactly. And they should, because we can do it, right? So, I mean, I don't think there's anything wrong with the expectations, but definitely more collaboration. A lot more collaboration would go a lot longer in the industry.
One other thing I'll just add to that is, the other thing is thinking about service and giving back. Actually, at my studio starts in about 15 minutes. And I'm going to meet my studio at a nonprofit, and we're going to be doing service work the afternoon for the nonprofit. And so, just trying to get a better sense of, how we can begin to make a difference out there. It continues that bottom up theme as well, right? I mean,
Yep.
you don't have to come up with the killer idea that's going to change everything. Those never work, right? Change happens one small step at a time.
Yeah,
right?
For sure. So for someone listening and they would like to get a hold of you, how would they do that?
Well, my email's out there and my social media accounts are out there. I'm on LinkedIn. I'm on Instagram. I have a profile on the UNLV website. If you Google me, Joshua Vermillion, it's one of the, all these things pop up in the first 5-10 results. I'm always available via email. I try to be really responsive, and I'm always happy to respond to feedback or try to answer questions, or I'm always interested in interesting ideas. If anybody has any or has any anything they want to say to me, I'm always happy to listen. Yeah.
Well, I want to thank you, Joshua, for participating on the podcast. It was a great conversation. I'm so excited that there's people like you out there thinking big about what the built environment's going to look like. Just how we use spaces, how we can change cities throughout a day. I mean, those are just mind-blowing concepts. I mean, it's just and then how do we use the digital technologies that are out there to actually, like you had a saying that said, "Smart people solving complex problems," or
serious people trying to fix serious things here, right?
Exactly. I love that. Right.
It's not just pretty pictures.
Yep. Serious people trying to do serious things, and I think that's great, right? I mean, and that's what technology is there for. So I really appreciate you participating on this. I want to thank the listeners for sitting around listening to the podcast. I hope you guys all got something out of it. Remember to look at the website to see future episodes and our blog posts and all the other DMA stuff out there, so you can see Joshua's stuff and all the other stuff that's being put out there. And I encourage you to look at Joshua's Instagram to see what he's producing with the bot. So thanks, everybody.
Thank you.